In this lecture, we're going to learn about the switch statement. And this is an alternative way to do what we did with these else-if clauses in the last lecture. Basically, testing for several different conditions, but it's going to be in a much more compact way than what we did in the last lecture. We are going to be using the exact same example we did in the last lecture, and we're going to look at the switch statement and how it works in C++. And this is how it works. We have our variable which is going to store the current tool, and we're going to say switch. Inside the parentheses here, we're going to pass the variable that we're going to be basically switching on or testing the conditions on. And inside the block, we're going to be basically testing for each case. So we're going to say if the current tool is the pen, we're going to say case pen. We're going to put a colon in here, and we're going to put the code we want to execute for the case where the current tool is the pen in these curly braces here. And one thing you should notice from the start is this break statement here. This is a statement that tells C++ that after we successfully execute a block of code, we're going to jump out of this switch statement. If you omit this break statement, everything after the case that you just executed is going to execute, and that's not probably going to be what you want. If this is not making sense yet, please bear with me. You're going to see it run in Visual Studio Code and you are going to understand. So what you're going to do, you're going to put all the tools you want to test for in separate cases. You see here we have marker, and after that you can put a default case that is going to be matched when nothing has been matched in whatever it is you have tested for in this switch block here. And when we run this piece of code, we're going to get exactly the same results that we had in the last lecture, but hopefully you can see that this is much more compact than the series of else-if clauses that we had in the last lecture. Again, the break statement is really useful. If you don't put it in, C++ is going to be confused, and after you hit your successful case, everything after that is going to be executed. So the break statement is basically telling C++, if you hit it after a successful case is executed, jump out of this switch block because you are done. You don't have to do anything else in here. And another thing you should know is that the condition, which is what we have inside these parentheses here, can only be an integer or an enum. So basically it can be int, long, unsigned, or char. Basically every integral type we have seen before, but it can't be another type such as string because that doesn't really make sense. So be sure to keep this in mind. Now that you have an idea about this switch statement, let's head to Visual Studio Code and actually see this in action. Here we are in our working folder. The current project is going to be switch, so we're going to grab our template files and we're going to bring that in here. We're going to go up a little bit and open this up in Visual Studio Code as we always do. And we're going to open up our main file. We're going to get rid of what we don't need. We are going to go outside the main function here and put in our tools, just like in the last lecture. We are using integers. Each one is represented by 10, 20, 30, up to 60. And these are the tools we have. And I don't think I explained this, but we are flagging them const because we don't want them to be modifiable. We have seen about const earlier in the course. We are going to jump into main and set up our variable. It's going to be int, and we're going to call it tool. And we're going to initialize this whatever tool we want. Let's use eraser, why not? And then we're going to put in our switch block. We're going to say switch. And if I type this, you see that Visual Studio Code is going to give me IntelliSense or suggestions on what thing I could do. One cool thing that Visual Studio Code does is give you snippets to really help you type things out. So we can click on this and it is going to autocomplete a starter version of our case. And we can type in our expression here, which is going to be what we're going to be switching over. So we're going to switch over the variable tool here, and we can put in our cases. So in our case, we're going to start with pen, which is what we have here. So we're going to say case pen. We're going to remove all this. Let's remove this and say pen. We're going to put a colon, and we're going to put a block of code that is going to execute when the current tool is the pen, and we're going to put that in here. Let's bring this to the right a little bit. And inside the block, we can say stdc out active tool is pan. Okay, so after that, we're going to put this break statement. If it's not here, we're going to have a problem, because when the current tool is the pan and this code here executes, every case after that is going to execute, and that's not what we want. We have to remember to put this break statement here. Okay, so we're going to put in all our other cases. So we're going to copy this and look at the next one. It's going to be marker. So we can go on the next line and put in marker. We're going to paste this in. We're going to say marker, and we're going to say active tool is marker, and we can keep doing the same thing. We're going to go down a little and paste this in. The next one is going to be eraser, so let's do that. We're going to say eraser, and we're going to say current tool is eraser, and we're going to go down again. I am doing this live because it really is important for you to see me type this. Otherwise, you may be confused, because this is a slightly confusing construct we have in C++. The next one is rectangle, so we're going to use that, and we're going to say current tool is rectangle. The next one is going to be circle and ellipse. So let's do that. We're going to put in circle, we're going to go down and paste this in, and bring this back a little bit, and we're going to say circle. And we're going to go down and put the next one in, which is going to be ellipse. And after that, notice that Visual Studio Code also inserted a default block. And this is a block that is going to execute when none of the cases here is hit. So this is really important. So you can also add a block of code and say no match found. Okay, so we want to see this print out, and we're going to try this out in a minute. Okay, after we do this, we should get this to work and do whatever we were doing in the last lecture. So the current tool is going to be eraser. The block here is going to be matched, so code here is going to execute. After that, we're going to meet this break, and what it's really saying is, you have done what you have to do, jump out of this switch block here. And we're going to go to the end of this switch block, and we're going to execute whatever is after that. So just like in the last lecture, we can say moving on. And if we execute the program as we have it now, it's going to say active tool is eraser, and it's going to print moving on. Let's bring up the terminal so that we can really see this. And we're going to build with GCC. The build is going to be good. And if we run Rooster, let's clear a bit. We're going to see that active tool is eraser, and we are moving on. This is really cool, and it is exactly the same thing we had in the last lecture, but now we are using a much cleaner construct which switch provides. Okay, we can try to change the tool and see that this really works. We can put in circle. Why not? We're going to build with GCC. The build is going to go through as you see here, and if we run Rooster, we're going to see active tool is circle. We are moving on. You can try and change this however you want. If we put in ellipse and build again, we're going to build with GCC. And if we run, we're going to get active tool is pan and moving on. Why is that? Ellipse, we are saying active tool is pan. We didn't change that. So we just code a really bad bug here. So let's fix this. And we're going to build again. I'm glad I found this. So we're going to clear and Rooster. And we're going to see active tool is ellipse, and we are moving on. Okay, so let's see what could happen if you forgot your break statement after your case here. So the current tool is ellipse, and it is the last thing we have in here. So it's not a good test case. What I am going to do is make the current tool the pan or the marker. Let's use marker. That's going to do. And I am going to remove the break statement here. Okay, so, and I am going to remove all the break statements we have until we hit the last default case. So we're going to go down, and we're even going to remove that for the default case here. And if we build, we're going to build fine. You're going to see that the build was good. But if we run this, try to guess what we're going to get. The current tool is the marker, so we should print marker and hit the end of the switch block and do moving on. But let's see what we get. Did we build? Let's build again just to be sure. So we're going to run Rooster, and notice what happens. active tool is marker, active tool is eraser, active tool is rectangle. We basically print every other case after the marker case is hit. And if we try to change this, for example, not use marker and use eraser, let's change this. You're going to see that we're going to match the eraser case, and everything after that is also going to execute, and it is not what you want. So let's clear and run Rooster. You're going to see eraser, rectangle, circle, ellipse, and no match found. So you have ready to remember to put in these break statements. I am going to hit Ctrl Z a couple of times and bring those in, and I think this is enough. We have to hit again so that marker also has it. And if we run now, we're going to get what we expect. Let's try to use an eraser again, and if we build again and clear and run Rooster, we're going to see active tool is eraser, and we are moving on. This is what we expect. Okay, this is really how you work with a switch block. You have to pass in your expression or your test case, and you catch each case using this case syntax here. You say case, you pass in whatever it is you want to match, and you put a colon, and you put your code inside this block here. And remember, after each case you have to add this break. Otherwise, everything else after this is going to execute, and it is not going to be what you want. Before I let you go, I want to show you that you can actually group these case statements if this is what is making sense for your application. So for example, for rectangle, circle, and ellipse, these can be grouped into the group of shapes. So we can actually say case rectangle and put them on different lines, something like this. So let's delete this and say case rectangle, and we're going to delete the other things and say case circle, just like this. And we're going to say drawing shape. I think this syntax is supported in C++. Okay, so let's try and build. And we're going to build with GCC. And the build is going to be good. So if we have eraser, which is what we have in here, we're going to say drawing shape. Let's clear and run Rooster. You're going to see drawing shapes moving on. We have grouped different cases and handled them with one block. And this may come in handy in some situations. One thing you should keep in mind is that there are limitations on what you can use as an expression or a condition in your switch statement. And that has to be an integer, something like int, char, unsigned, short, or things like that. We have seen all of these things, but it can also be an enum. But enum is something we haven't learned about yet. We will learn about it later when we have enough tools to understand that, but know about this limitation. So if we came in our project in Visual Studio Code, for example, and say std string name and say John, for example, and use this as a switch condition or expression, we have to include string for this to work. So let's go up and include the string library. We're going to do string. And if we go down again and try to do switch and use name as an expression and take out everything we have in here and try to compile this, you see that the compiler is not happy. Okay, it's going to say expression must have an integral or enum type. So this is not even going to compile. This is a limitation you have, and you have to make sure what you pass as a condition here is an integer. Something like int or char or other integral types we have learned about in this course. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about short circuit evaluations.